And in this video I'm going to be going through all of the number topics that appear in the GCSE Foundation Maths paper for OCR. One of the first areas that you'll want to look at is making sure that you can add, subtract, multiply and divide without a calculator. This is going to include negative numbers as well as just positive numbers as normal. Being able to use any method should be suitable. Just make sure that you are confident in how it works and that you'd be able to get the correct answer at the end. The next area is definitions of terms related to number. So this would be understanding things like odd and even numbers, prime numbers, knowing how to find factors and multiples, understanding what a common multiple and a common factor is, square numbers, cubes, cube roots, and then the place value system. Now to the right there are a list of examples as to what each of these are, and you should know most of them. People do often forget prime numbers, and it's important you're able to know those up to about 19. Square numbers, understanding how they work along with cube numbers, and then their roots and how they go back. What I do find when marking papers is that often people forget the difference between a multiple and a factor. So your multiples are your times tables and your factors are what go into a number. So I've given the factors of 12 as an example. Lowest common multiple and highest common factor will come up later, but understanding what the idea of a common multiple and a common factor is between a pair of numbers is also important. The next section is looking at prime numbers, and as already mentioned, identifying prime numbers less than 20 is something that you're expected to be able to do and know, as well as generally knowing what prime numbers are, so only having two factors. Expressing a number as a product of prime factors often uses a prime factor tree, as I've given below, and understanding that this can actually be done in more than one way. So although 144 has been broken down to its prime factors, knowing that it can be done in any different way, but it will still lead to the same answer is an important part. The next thing is to make sure you do right answers as a product of prime, so that it's all those prime numbers at the end multiplied together, and then also writing it using index notation, so being able to write it in terms of powers as a simplified form. Do read the question carefully so that you do write down the answer in the format that it is expecting. Along with common factors, I mentioned highest common factor and lowest common multiple, and there are two particular methods you should be aware of. The first, as is mentioned above, is to do it by listing the whole numbers. So actually writing out all of the multiples and all of the factors, and then actually finding the one that matches that you need. However, the other method is to ensure that you know how it works with prime factors. And so the diagram that I've shown here is a Venn diagram where you've got the prime factors for two numbers put into the diagram. Where you've got your intersection or your overlap, that is where any prime factor that is common will go, and the remaining prime factors go into their respective circles. To get your highest common factor, you multiply the factors which are in the overlap, and then to get the lowest common multiple, you multiply all the numbers together that you see in the diagram. So although those numbers overlap in the middle, do not count them twice, just only count them once. So in this case, there are 7 prime factors in the diagram. You multiply all 7 together. The next one is understanding about the priority of operations, or what would be referred to as BIDMAS, understanding the order and how that actually applies, making sure you don't start moving things around. So if you are doing a calculation further on to the right, don't just bring that number to the left, which can be a common mistake. Some questions ask you to put brackets in to make sure a calculation works. Another question can well have multiplication and division all in a row, and if that's the case, you will work just left to right on those. Be aware also that with indices it could also include roots, so you want to make sure that you are familiar with those. Most questions on this are fairly basic, but BIDMAS, or the order of operations, applies in every context. So in every kind of question, make sure that you're actually using it. Understanding inverse operations will come up actually more with algebra, generally in an exam, but understanding that there are inverses to certain calculations that you would do. So add and subtract are the inverse of one another, along with multiply and divide, power and roots. And so often you'd use inverses to solve problems which are often given in words, like the example to the right, and you actually have to figure out a number given a bit of information. Other questions which were shown in the example are about missing digit problems and being able to understand how to work back. There is also an example of doubling and halving here, but that's not necessarily as common in the papers as other areas. So inverse operations will come up more with algebra than it does with general number work. The next one is looking at the idea of equivalent fractions and also being able to convert between mixed numbers and improper fractions and understanding how that all works. You will need to know about equivalent fractions and simplifying fractions in order to do more complex fraction work. It's unlikely these will appear as a basic question on their own, but that could be at the start. So knowing that you want to find a common factor when you're trying to simplify that you can divide through. Most common mistake is always trying to divide by 2. Look to divide by a common factor, and the largest common factor or highest common factor would be best. When converting between mixed numbers and improper fractions, make sure you multiply the whole number at the front by the denominator and then add that to the numerator to give your numerator at the end. This can be very helpful when adding and subtracting mixed numbers together. Calculations with fractions are something you're going to need to be able to do, which will include the add, subtract, multiply and divide. Being able to recognize the standard method. So when you're adding and subtracting, you need that common denominator, the same denominator before you begin. With multiplying and dividing, you will not need a common denominator. If you have mixed numbers, it's usually best to ensure you put those as improper fractions first. And for division, you want to remember to invert and multiply. So turn your second fraction upside down and then use the standard method for multiplying. Be aware of BIDMAS again. In the second example on there, we've got an addition and a multiplication with fractions. So make sure you use BIDMAS as appropriate. Fractions of a quantity or fractions of an amount is a fairly standard question. It may also be that you'll have to work in reverse. So you may be given an answer and you'll have to go back to the original. Being able to represent one quantity as a fraction of another can usually involve some different units. So when finding fractions, divide by the denominator, multiply by the numerator, and you'll have your answer. Typically a standard non-calculator paper question, and usually something that would be nearer the start. Understanding basic equivalence between decimals and fractions. There are certain basic ones that you would be expected to know. So I've mentioned a few down there. Knowing what an eighth is as a decimal will be helpful as well in a few questions. Being able to add, subtract and multiply with decimals, they typically will involve standard methods like you would use with whole numbers, but usually some sort of additional work goes into there to make sure the decimal point is not an issue. So with multiplying and even dividing, you'll want to make sure the decimal point is removed. The division of decimals is what comes up next. So with division, as long as you multiply both values by the same power of 10, so 10, 100 or 1,000, I should say 1,000 in there, you want to make sure you do that so that at least the second number in the division is a whole number. That will make this a lot easier. Percentage conversion, so knowing how to go from percentages to decimals to fractions. Percentages are usually quite a nice one, particularly to get to fractions, and then also dealing with it if the percentage is larger. Percentages are rarely used in probability, but it can be helpful to have that as a conversion in there if you need to. Percentage calculation, so knowing that percentage means out of 100, usually then being able to calculate a percentage of a quantity, finding like 10% and 5% and being able to do the standard non-calculator methods. Then one quantity as a percentage of another, so typically done by a division, and then converting that decimal into its percentage. Also, you've got being able to use multipliers. So a standard multiplier for an increase is to add your percentage to 100, divide by 100, and you'll get 1 point something. And then if you've got a decrease, it would be to subtract it from 100, and then your multiplier will be 0 point something. This is typically on a calculator paper, and these can be quite nice questions. They like to use sort of banks and things like that and interest rates. Reverse percentage change is probably the most difficult part here, or finding the original value after a percentage change. So this involves a reversing process where you'd want to divide by what would be the appropriate multiplier. I've done a separate video on this, and you may want to look that up separately. Ordinality, which is the basics of just putting things in order. So if you've got fractions, decimals, and percentages, convert them so they are all the same. In the case of fractions, get a common denominator. But if you can, I would normally go for decimals or percentages because I find those easier to order. Understanding certain symbols, so your less than, your greater than, equals and not equals to at the end there, so that you know when it's appropriate to use them. Most questions are about just dropping that symbol in as and when it's appropriate. Index notation, which was mentioned earlier, but being able to write numbers using suitable powers. Also understanding that a negative power may well be used and would represent reciprocals. It does come up in the next slide, but understanding how index notation works. The number of times you see people in this case who, when they see 2 to the power of 4, would write down that the answer is 8 is a lot, and so you want to make sure that basic is not overlooked. Calculations and estimations of powers and roots. So understanding how powers and roots work. There have been questions where you might have to estimate with a square root and you sort of look at what it's in between. Those are sorts of things, but simple powers of 2, 3, and 4, and 5. So knowing 25 is 5 squared and things like that. So it goes back to the squares and cube numbers. On the right, you can see an example, and also at the bottom, about a negative power and integer powers and how that actually works. I've written the example at the bottom just to show a middle step. So if you have a negative power, it is in the fraction form will be 1 over the positive power of that. And then you evaluate that positive power, and then you'll get your overall fraction. This will usually be a standalone question, just one of these, and usually worth a mark. Knowing your index laws and applying those, typically it can be an algebra type topic, which is why there's a lot of algebra here. But you do also want to apply that with numbers as necessary. So there are a few examples here which provide like a variety. I'm not going to go through them all. You can have a look at these and see how they generally work. But recognizing when to add and subtract your powers, and it's as long as you've got that same base that you can do that. Division may well look like a fraction, and so it's about understanding how you're going to work with those effectively. Some of these examples here are will probably be mid to late on in a paper rather than anywhere near the start. Standard form, being able to convert numbers in and out of standard form, and recognizing that how the number at the front is between 1 and 10. And also understanding how negative powers here do not relate to negative numbers at the end. They just relate to smaller numbers or numbers which are getting closer to 0. Being able to perform certain calculations like add, subtract, multiply, and divide. Sometimes this appears in a calculator paper, sometimes it does not. So you want to make sure that you could sort of work your way around either way. Some of the more complex ones, when you do the multiplication, particularly, you will not have a number at the front which is between 1 and 10, and you'll have to compensate for that. Exact calculations, so this might well be a case where if you're dealing with sevenths, you will not want to necessarily go decimal, as sevenths do not work out very nice. So being able to actually use fractions in your answer, so giving something as 4 and 2/7, for example, would be more appropriate. Also recognizing how to write in terms of pi. So this could be in a non-calculator paper, so in which case you wouldn't want to use 3.14, you wouldn't want to go decimal unless it tells you to. So if you ever see it saying in terms of pi, use pi as a symbol at the end. Rounding and understanding how to round using decimal places and significant figures. Most people are okay when it's the nearest tens, hundreds, and thousands and so on, but recognizing how decimal places and significant figures are different. Significant figures is essential for your estimation work and being able to round to one significant figure. Okay, very few questions on rounding are necessarily here's a number and round it. It could be 1 mark at the start, but it's more likely to be embedded as part of a bigger problem. So at the end you'll have to round and use that appropriately. As I mentioned, estimation, you want to make sure you can round numbers to one significant figure in order to actually estimate the value appropriately. So if you don't round to one significant figure, what will sometimes happen is your answer will end up being worse. It will not work out. So you might think that you're rounding a number nicely. So you might have, say, 32.3, and you think, oh, if I round that to 32, I'll be fine. Round it to 30, round it to that one significant figure, because the question is usually designed to work better if you do. So make sure you can do that and understand about your answer at the end. What does it actually mean? Does it seem sensible or appropriate? There is also the approximately equal to symbol, which is referred to at the top there. You want to make sure you know that symbol and when it may well actually appear. Understanding upper and lower bounds can be referred to as greatest or lowest value. Most questions on this have been about rounding to one decimal place or two decimal places and coming up with an appropriate error interval as an inequality. What is rarer is about truncated values, which is where digits are removed after a certain point, and that has a slightly different way of rounding. So error intervals like these, they typically appear as a one-off question. They're worth about 2 marks, and they can be actually 2 quite easy marks to pick up. So making sure you can use that inequality notation when it's appropriate. That middle part always looks the same. It's just the numbers on the left and right which will vary. Equivalent ratios, so being able to actually write things in the ratio format, and then going for unit ratios or in the form of 1 to n. What you need to recognize is that n can be decimal in this case. Most ratios it's not. This will be one of the only cases where it is. And then also recognizing that if you are working with different units, they need converting to be the same unit. Make sure you fully simplify where you have to with a ratio, because the question will expect you to do so in order to get full marks. Division in a given ratio or sharing in a ratio can be a fairly standard question. It could just be as straightforward as here's an amount, share it in this ratio or divide it in this ratio, and there's a standard 3-step process for this by adding, dividing and multiplying. It's not difficult to do as long as you can recall that process. What you do have to understand is that most questions now in the 9 to 1 GCSE will be set up a bit more in a more complex format, and so you may end up with 2 separate ratios that share a particular common part to it. So one example in a question was you had cows and sheep, and then you had sheep and pigs as 2 separate ratios, but they both contain sheep, and so you had to work with it there. Other questions can be that in an amount of money shared in a ratio that someone gets a certain amount more, and you have to then work with that. And so it's about that gap between the values in the ratio and making sure that that matches the gap given with the question. Difficult to explain, but they have written some fairly tricky ratio questions, and so you have to start to realize that sharing in a ratio as a normal part, that's fine, but there can be more difficult ones. Understanding how fractions and ratios work is quite important, particularly if you want to share in a ratio in that way. Most people do get the idea of how a fraction and a ratio work or equivalent very wrong, and they often use ratio and probability when they shouldn't because they will use it incorrectly. So in this example, the ratio 2 to 1 would actually split into 2 fractions of 2/3 and 1/3, 2 out of the 3 parts of the ratio overall. Some people in this kind of ratio, particularly if it was 1 to 2, would say that's a half, and so you have to make sure you know how ratios do work with fractions. It can be useful to draw out a little diagram and then some shading, and then you can see what fraction of the diagram represents either part of the ratio. So solving certain types of ratio problems that usually involve proportion are typical recipe problems. A standard method would be to find the recipe for one ingredient and then multiply up to whatever you need. Again, questions can get more complex, like have they got enough ingredients to make this many? And so you may also have like a limited amount of ingredients to work with, and how many can you do? So you've got to understand that the standard question's nice and that might come up, but the more complex one could come up. And so you want to really think about how you're using a method. You don't always have to go down to 1. You could find that if you get your recipe, like it says, the recipe for 6 for 4 people. So if you were with 6 people, you might say, well, I can find it out for 2, and then I could subtract it, or I could double it. There's different ways, but you have to recognize that these ratio problems will get a bit more difficult even in these recipe contexts. Understanding direct proportion, knowing that as one value increases, so does another one, but in the same way. So a standard example of this, it mentions currency conversions. So if for argument, if £1 was $1.50, then £2 is $3, and so on and so forth. It will go up equally. One of the things also with direct proportion is understanding how it links to a graph. So it's a straight line graph and it will go through 0, 0. So if you had £0, that's $0. It's not going to convert. So direct proportion should keep equally going up like that. At no point should it stop. Certain problems involving direct proportion usually involve finding how many times bigger something is than another. You can think of it like scale factors in terms of how it links. Inverse proportion can be a bit more complex. The example I've given here is probably not a great one because it might well be from a higher tier paper, but it gives this idea about how inverse proportion works. And that is if one value increases, another value would decrease. The example at the top is where they talk about speed time context. So if you double your speed, then the time it's going to take to cover that same distance will halve. And it's understanding that relationship between two values. More formal problems are where you are told a particular relationship between values, and then you have to figure out how to get one value given another. It's a bit weird in how they phrase them. One of the things about inverse proportion problems is that if you are given some initial values to work with, the standard process is to multiply them, and then that value is kind of fixed. You've always got to get to that value. And so if you do that, you should find that you can work out the other value by a little bit of division. So I've tried to give an example of this. Inverse proportion can be quite rare, and they are normally these sorts of more simple problems. Growth and decay, typically these involve financial situations where a certain value would increase or decrease by a certain percentage over time. Most standard problem with this is compound interest, or it can be depreciation. So you want to use multipliers. These are typically calculator questions. It's very rare that these will be in non-calculator questions. The only thing I found that most people find difficult is if the term simple interest comes up. So you want to make sure you know how simple interest works as well. So this does link back to the percentage change, so using that multiplier, but you'll want to use it more than once. You might also want to use a power for your multiplier if it's an interest rate problem over a period of years, as your power will be the number of years. Now that will be the end of the video, and hopefully that's helped some of you get an idea of the kind of number topics that you're expected to know, the kind of ways in which it can be incorporated in an exam, and hopefully it will help you guide a little bit of your revision. Try and target areas that you were not so confident on, things that you have come across in this video that perhaps are areas that you think you've forgotten about, that you've not looked at, or ones which need a bit more work. You can search through YouTube, there's lots of videos to help you with these. Try and focus on keywords and you should be able to find them. But if not, do see your teacher, ask them for help. They'll be delighted to help you if you need it, to ensure that you do your best. So all the best and good luck.